Good day, folks. Nice to see you. Again, my name is Craig Shutko, Director of Digital Delivery. With me, I have Dylan Barkowski and Brandon Bouchard, who are developers who both worked on this particular product. To give you a little bit of an overview of what we did, long story short, one of the things AI is good at is interpreting data that's not very human readable. So if any of you have ever worked with legal services or read actual law documents, you can understand they're often difficult to understand, they're often difficult to interpret in sort of human plain language readability. And really, we were out to kind of sort of solve that problem. The Procurement and Supply Division in Citizen Services owns the BC Laws data. All that data is accessible on a public API, so it was easy enough to ingest and apply AI and AI-related things to. This is just a shot of our team, so important thing to note is we actually had no contractors or contract help on this team. This product was built completely in-house by developers with the government, and that made for a whole lot of learning and a great experience. And ultimately, with this particular product, that's what we were after. This was kind of a product of AI taking off, us being like, let's experiment. Let's start working with these things and building AI-enabled applications so that we can understand the principles and what it takes and what sort of a development team it takes and what costs are to run these things in production, so that we can essentially and ultimately advise other groups in citizen services of what to expect when you undertake an AI or AI-related product. So this is just a couple of the things that we were hoping to do: learn technical skills, learn how to train and adapt AI models. I mean, model selection, I think, is probably one of the most important pieces in all this. Determine a repeatable pattern. So we really focused on that common idea of if someone can take the work we've done, attach it to a new data source, and repeat the same thing we've done. And then the last piece is just some best practices. So this is a really simple slide on just how things work. We ingest the BC Laws data from the publicly available API. One of the reasons this use case was important is because that data is publicly available. So ChatGPT can also access that data. Google Gemini can also access that data. So as we built this app, we could compare the results with these other applications and see, are we actually adding value beyond that or not? Long story short, it's a classic RAG application. Users via a web interface ask it a question. The application runs the search results through an LLM, and it comes back with a human-readable response about whatever the question was. So why did we build this app? What was kind of the business value we saw? So we saw a lot of potential time savings for policy analysts and law librarians. There's a lot of people who field questions about BC laws from citizens, and they're professionals and know how to interpret the laws and understand them. So this is potentially be a time-saving tool for them. Again, back to that developing key data and development skills. We didn't have a lot of data skills in-house in our particular department. So that was, again, key. And again, reiterating that last point, build a template that can be used for other AI use cases across our ministry and government at large. Some of the design principles we use. So obviously, there are AI guidelines published for all of the enterprise of government, and we made sure to adhere to those strictly. But these are some design principles that I think are really important. We talk about the dangers of AI, particularly in the public use. First and foremost was always having a human in the loop. So that means that an expert checks the result before it's delivered to a client. Second key design principle was always making results traceable. So on this application, you can tell where the conclusions came from, and you can trace it back, so that in the case of a hallucination or something like that, you can figure it out and untangle it. And then the last piece is really always allowing for continuous improvement by human experts. There's challenges here in automating that, taking the feedback and retraining the application to include feedback, but it's important that I think these things improve over time. And then the last thing that we really tried to do with this was implement in multiple stacks. So we'll try to touch on this a little bit, but we basically have done sort of an internal data center implementation that uses our OpenShift cluster in government as well as AWS to run the application. And we've also built it in a classic GraphRAG all in Azure so that we could kind of compare costs, compare results, and see what actually delivers more benefit. Okay, now I will show you the app, and then we can go on to a little more technical discussion about how it works. So it's a classic chatbot. You log in. It's all single sign-on based, so it works with your government account automatically. We have the notice that comes up just warning you, hey, this is AI, we're experimenting, things could go wrong. This is the main interface. You can see this is our ethics and safe commitment to AI pieces. This all reflects the AI principles in government. And then you can just ask it a question. There's sort of 4 simple ones to choose from. And so the question asked is, do I need to wear a seatbelt in BC? And you can see it comes back, sort of gives you a human-readable interpretation of what BC laws say about using a seatbelt. And then these are the references. So it references every section of every act that it gathered data from to return the response that it did. So you can see very easily where that came from. And then obviously we have the feedback loop, where users can leave feedback on this response is good or this response is bad, and we can incorporate that feedback into retraining. Okay. So I'm going to ask Brandon to come up and talk a little bit about the tech stack.
Thanks, Craig. Yeah. So, of course, we've got Neo4j, that's the graph in GraphRAG. This allows us to create the context and tie together the entities that we're working with and how they relate to each other, which we then dive further into with other technologies to make it even more contextually aware. We have a part of the templating that Craig was alluding to largely kind of focuses on this ML data ops portion, and that's kind of how we're automating the ingestion of data. We're automating basically the whole ETL, the whole extract transfer process, and then the training. We want that to be as automated as possible. Similarly with the feedback that we're getting, we want all that to be ingested as automatically as possible. Tracking, this is where we're seeing, we're collecting that feedback that Craig was talking about in the tool, and then we can actually visualize that using superset. It's kind of run through a few different services, but superset's how we're going to visualize that, how we do visualize that. And then we can show that to people, we can show that to ourselves, and it gives us a bit of an idea of whether or not we're going in the right direction or the wrong direction. The active feedback, this is the part I'll focus on here, diagram. This is how we annotate. This is how we give meaning to the sections, the acts, make sure that the context is being appropriately assigned. And we host that in OpenShift. This allows the team to work collaboratively to do the annotation as opposed to siloed off in their own local environments. And the last piece I'll touch on for this, which is a huge portion for us, especially early on when it came to how do we kind of index the initial intake of data. It's a high performance compute, so we're all pretty familiar, I think, with the idea that GPUs are the de facto technology, the hardware that we want to use to process large quantities of data. What I think is less known is that specifically in our OpenShift cluster, we're using Intel Xenon processors with the ABX512 instruction set. Basically, it means we can use them for AI purposes, and they're very good at it. The size of data that we're dealing with, the type of data that we're dealing with, it's quite viable. We don't actually have to worry about these GPU resources at the scale that we're at. And then, yeah, the speed that we see is because we're able to control the thread and then like parallel compute. So instead of waiting synchronously for actions to happen and then another action happens, we can say, do it all at once as much as you can. I'll leave it at that for this part, and I'll pass it off to Dylan for some of the architecture overview.
Great, thanks, Brandon. This is a kind of a rough snapshot of our architecture. It's always evolving. What you'll see is essentially we can break it into 3 parts. The indexing portion, where we're taking our data and we're formatting it, we're indexing it, applying those vector embeddings, and inserting the Neo4j. And Airflow is a big part of that. We want it to be native. We want it to that we don't always have to go and trigger this manually. The laws change. They change a lot more frequently than we might expect. We want these to be repeatable, that when new stuff comes out, this stuff is getting indexed. The main portion, more of a traditional part of the application, you see in the center. There's the back-end portion of it, and it's just being the middleman in this case. It's taking the user's query, it's applying those vector embeddings, looking to Neo4j to say, what's the most similar pieces of data that match the user's query. And when it comes back with all of that context now, all of that piece of information, we can send that off to the third piece, which is AWS. We're just using essentially to host our LLMs. And we have a nice choice of LLMs there. We've experimented with Mixtral, we experimented with Claude Sonnet to see different results. And then once it comes back, we can send that back to the user. And as you saw in the demo there, the front end will show that LLM generated response and all the references. And those references correspond to that data retrieved from the database, Neo4j. Finally, there's that tail piece on the far right, and that's like our analytics piece. So whenever someone is making a query, we want to know how it went. Did it take a long time? What kind of responses did they get back to the question they asked? Were they happy with it? And if not, why? And we track a lot of that. We can track things like, are they spending a long time looking at a particular source, right? Or did they not bother clicking on any sources? And all that data we can take together and hopefully apply back to our original data set. We wanted to improve, hopefully, the context we retrieve and get better and better answers from the LLM response. One thing you might notice in here is that indexing process and the application process all in OpenShift. So the only part that we really look outside for at the moment in the live demo is the AWS portion. I think that I'll pass it back to.
Yeah, so just a few keys to the implementation. One of the reasons we want to use OpenShift is it's available to us. It's already something that governments are using. You don't have to worry about Azure being a platform that is going to change and iterate on itself, or their costs might change. We have a lot more control over our OpenShift environment. We've got a note here about how it's $220 per month. This is kind of an at-rest dollar figure because we don't know at large-scale load, but we do know with Azure, we have a rough estimate it's going to cost about 10 times as much just to run the VMs, because you actually must spin up virtual machines before you can start running operating. Of course, in Azure, you need some kind of hardware to perform the operations, and in OpenShift, it's already there. And we get provisioned it by platform services, and then it's a cost based on usage. I talked a little bit in my previous slide about the Xeon processor, AI-specific instruction set, so we have that too, that is key. And then the last point here with the challenges with MLOps and data ops. These tools are already new. Everyone here, I think, who's been working with these tools knows that it's like every month, if not every week, they're changing. One of the things I've noticed as the DevOps resource on the product is that they're not really built with compliance in mind or security in mind necessarily. They're kind of built to perform their job, but not to do it in the most compliant or secure way. So we do have to work around, like with Airflow and Diffgram and stuff like that, where they want to run as a super user, and we don't, by default, allow that. We don't want to allow that. So there's a bit of work that we have to do manually in that sense when we're setting up these environments and setting up these pipelines to enable the teams to be able to use the tools effectively. So something to note if you're going to copy this pattern. I think that's back to Craig.
Cool. Sure.
Okay,
Oh, did you want to?
sure. Just some of the things we touched on. We're always learning. It seems like every day, like Brandon mentioned, there's a new tool, and we're encountering new challenges to face. So the first one that obviously came up there is that there's a big cost difference between the Azure and the OpenShift implementations. Part of that also we're looking at is like, what is the actual response difference? Like, is the cost worth the difference in quality? Like, are we getting good responses back from both, or is one clearly superior in some way? You talked a little bit about the return on investment. I think, Craig, you might be able to spend more.
Sure, yeah.
But you mostly work with law librarians. Small group, right? So the amount of resources we're committing to this group tends to be maybe a little bit larger than the cost savings for that particular solution. MLOps is hard. As maybe it's an understatement, but like I mentioned, there's a lot of different tools that are going. So when we talk about like repeatability, and we're looking at tools like Airflow, that's unfortunately just like the top layer. We're also talking about like how can we connect all these different services in a way that it just continues to function without hopefully too much intervention. One aspect of that is data. We realize that as time goes on, the data is changing. How do we version it so that as we continue to add new data and we're experimenting, we potentially can look back at older sets, and we end up using tools, one such as DVC, and imagine that as like Git, but for data. So we can commit essentially the entire versioning points of data and roll back to them as needed. And then some of the challenges in getting things running, it's not just an OpenShift, but that sometimes it's an OpenShift and the connections to outside. So we touched on like the Azure implementation. There is definitely a lot of roadblocks and policy unlockers. So we have a team member who has been working with Microsoft and Cloud Services constantly they'll move forward and they'll find a new policy that unfortunately has to be navigated. And it's that continual forward, one step forward, one step back, two step forward kind of approach until we've actually punched all the way through.
Cool. Thanks, guys. So a couple more learnings on the sort of strategic level that I think are really important is like, so one of the big ones for us was that value in AI applications is achieved over time. When you first, it's hard to do a POC. When you first produce it, you've got AI results producing, 60% good answers, 40% bad answers. So I think it's really important to plan for that when you're building an AI-enabled application like this, that like really your initial POC results are going to be worse than it will get over time as you train it. And I think it's important to factor that in, because that's different than I think in traditional software development. Second piece that we kind of learned from doing this is AI is often only a partial solution. I think that it's really important to focus on solving a problem and then ask how AI can help it, rather than focusing on what can I use AI to solve. And I think that that's critical, and we really need to reverse that thinking, particularly in government sometimes. Again, the automation LLM systems aren't 100% consistent, and that's where that human oversight, I think, is mandatory until particularly the product is well trained and well tweaked and well, and precise. And then really what that leads into, and this kind of relates to the first point, is the service design process, I think, is incredibly important to really tightly understand how this application is going to help your users, so you can quantitatively and qualitatively understand the return on investment and how this is helping people and how it's saving them time is really important. Like in this particular product, we were kind of going from the experimentation domain. So in the end, it's like it helps the users, but it doesn't like dial help the users. So I think if I did this again, really doing some service design, some design work up front, working with the users to understand what they need is incredibly important in the AI space. And then lastly, this is kind of what we're working on next. GraphRAG implementation, user testing. Are the results better? We're experimenting with new LLM models, and we're trying to run a completely automated MLOps pipeline so that any feedback given is automatically retrained into the system and helps. And so that's it. We're happy to take any questions you might have. Thanks.